तिम्रो पुरानो भर्सन होइन तिम्रो पुरानो भर्सन एउटा
Hello, test, my test. Hello.
Yeah. Divya, can you hear me?
Yes, Dai, I can hear you.
Mic completely mute on one.
On mute करो ने. Oh. Sound.
Hey, Philip, do you want to present something? Like load a slide?
Yeah, I think let's try one.
What do you want me to throw up something?
Yep.
Philip is already on the higher version. Can somebody from the lower version present to the present?
Let me just do a share screen. I'll just share screen.
Participant this channel वाले.
You can have that just as a screen.
Yeah, I see your screen.
Yep.
We need someone on the older
See the
version
segregation
of the
versus-
software to present something.
Yeah.
Anyone on
I'm in the Swedish data center now, if that's better or not. I don't know how I ended up there, but it might be better than what we have up to now.
Hi,
Anyway,
Philip, we can see that.
Good, I'll stop
I
the
can see
share.
the screen.
के भन्नु केही नभन्दैन
Has anybody there in the attendees got a older Zoom client while we experiment? We can promote you to panelists just to try out if this is working. Can you try sharing something, Paresh?
Sure. Give me a second.
But you're on 549 as well, aren't you?
I am now. Let me see. Can you see that now, Philip?
Yes, no problem.
Brilliant. Okay, so I'm good.
Is Drew on the attendees?
Yes, I'm moving to the panelist.
It's okay. So basically
Yeah, and we probably should test Subin as well, just to make sure. And maybe that's part of the trick that we need to do after this session as well. I'll check with the others.
Did you force everyone to be on encryption also?
No, not this time.
Okay.
All right, so I can see Dhruv and Subin both, Paresh as well. So yeah, Paresh, please continue.
Yeah,
This
hello
is
everyone.
good. This might be a session that actually works. Woohoo!
You guys can see my screen?
Yep, I can
Yep.
see it.
Oh,
Now we have to wait for people with old clients to say, oh, we can't see it. But hopefully this will all work. Oh my gosh.
Hello Paresh, how are you doing?
Hey, Subin. Good. How are you?
Yeah, I'm fine as well.
Finally
I'm really
get to.
grateful to you for reviewing all my slides for the final presentation.
No, it's a pleasure. Thank you for contributing.
Mm. So we start at 1 p.m. local time.
Yeah, I'll do a quick intro and then I'll hand it over to you. So maybe I'll give it a few minutes.
Okay. Can I try to share my screen if to make sure
Yeah,
that things work?
please do so.
Yes, please.
Thank you.
It's good to me.
Yes, looks
Is,
good here as well.
is my slide visible?
No, not.
ठीक से Subin sir.
Okay, thank you. Okay, I'll stop sharing and now only share it when take my turn.
Not a problem. Thanks. Guys, are we ready to kick this off?
Hi, Paresh. I think we can move forward.
Excellent. All right, everyone. Welcome to the second of the technical plenary sessions for SANOG 36. So for those of you who've joined the earlier sessions, welcome back. For those of you who are joining for the first time, welcome to SANOG 36. So as part of this session, which is an hour long, we've got two presentations, two very interesting presentations, I must say. So the first one, actually, before I do that, maybe I should introduce myself. So my name is Paresh Khatri, and I also have the pleasure of being associated with SANOG for quite some time. I believe SANOG 12 was the first time I joined the event as a presenter. And it's been great to see it grow from strength to strength over the years. So I'm based out of Brisbane, Australia. I work for Nokia Networks, yeah, it gives me a lot of pleasure to be chairing this session. So I've got two very interesting presentations for you today. The first one will be by Subin Shrestha, and this will be about how we optimize service provider MPLS networks by the use of a technique that we call hierarchical VPNs. And then the next session will be something that's actually, cutting edge, which is about IETF network slicing, something you may have heard about in relation to 5G, but it actually goes beyond that, as you will see. And that will be presented by Dhruv Dodi from Huawei. So my first presenter, Subin Shrestha, is a senior engineer with Nepal Telecom. He's been working with them for about 10 years now. And he's been operating a carrier grade IP MPLS network. So we're hearing from the horse's mouth as it is. And he dabbles in a lot of technologies. I will not go through the list. It's a very long list. But his latest one here is about how we scale VPN networks. So over to you, Subin.
Thank you, Paresh, for that nice introduction. and namaste and hello to everyone. It's a good sunny day here in Kathmandu. So good afternoon to everyone in Kathmandu, and good morning, good evening to everyone in their respective time zone. Let me introduce myself. I am Subin Shrestha from Kathmandu, Nepal, and as mentioned by Paresh, I'm currently working as a network engineer at Nepal Telecom. It is an honor for me to speak in a SANOG conference, and I'm really grateful for the SANOG team for providing me with this opportunity. So today I'm going to talk about how we can optimize the service providers network service providers network, service providers IP embedded network with a technique called hierarchical VPN. So I have divided today's presentation into six subtopics. So firstly, I will describe the service delivery mechanism in the MPLS network. Then I will describe how the IP network has evolved in the service providers and the problem associated with each IP network evolutions. Then I will come across the solution for those associated problems, and that solution would be, let me reveal, it would be the deployment of HVPN. Then I'll talk on the basics of HVPN, followed by how we can configure the network for running HVPN services and how we can successfully manage and monitor the network. Then at the end of the presentation, I will share our experience of deploying HVPN in our IP-MPLS backbone transmission network. Now, let's discuss how we can deliver service in MPLS network. Well, in MPLS network, services are catered using VPNs. And what does is they create a tunnel from source to destination so that the customer's services can be run securely in an service provider's IP MPLS network infrastructures. The services in VPN are allowed to communicate with each other as per the customer's requirement, and it provides flexible interconnectivity for the customers. The VPN services in MPLS can be delivered into mainly into two different ways. One would be the layer 3 VPN whenever the customer requires layer 3 connectivity, and other one would be layer 2 VPN connectivity whenever the customer requires layer 2 or direct connectivity without any routing requirements. Talking about layer 3 VPN, is the customer end router pairs with the service provider's P router, and as per the customer's requirement, the customer can run any protocol that they want to, and the P router configures the adjacent routing protocol that the customer router is being running. And what the P router does is it maintains a separate routing table called VRF for each VPN, the policies of which are defined by the VPN customer. So whatever the VPN customers demand, the service provider makes necessary changes to the VPN policies as per the customer's requirement. The routing from one customer is, of course, isolated from other customers because all the customers are now in a separate tunnel. So one traffic in one tunnel cannot talk with another tunnel unless explicitly allowed by the service provider. And because the tunnels are well isolated, there are no constraint on IP address plans and implementation when it is done for the VPN customer. And the P maintaining separate routing table is called VRF when in a layer 3 VPN term. So this was about layer 3 VPN. Now let's discuss how layer 2 VPN service is facilitated by the service provider to the customer. In layer 2 VPN, what the service provider router does is it just emulates the behavior of layer 2 LAN across its own IP MPLS infrastructure network. There would be no routing between customer and service provider. However, the service provider can provide point-to-point connectivity or point-to-multipoint layer 2 connectivity as per the requirement from the customer. Now let's look at how the IP network has evolved in the service provider. At the very beginning, when IP MPLS network was started to be used as a transmission network in a service provider, only core level equipments were operated with routers. The aggregation and access, they were operated using layer 2 switches. And the problem with the aggregation and access switches being operated with layer 2 switches were that there was a lot of unwanted broadcast, because all the broadcast would mix at the uplink, and the uplink would be congested even though there were no actual traffic. Not only that, because the layer 2 STP ring need to be run in the layer 2 ring, there were lots of frequent reconvergence because of STP recalculation. Thus, this type of network was not deemed stable as from by the network provider, and the network provider looked further to improve this network. And what the service providers did in the second evolution was they just thought of replacing the aggregation switches with the aggregation router. When this was done, there was a significant reduction in the broadcast and frequent reconvergence of the network up to the aggregation layer. However, the problem still was present in the access layer because of the layer 2 switches that were deployed there. The same problem of broadcast and frequent reconvergence now got shifted to access. Now the uplinks of the access were congested. There were no problem up to the aggregation. However, is as the access network is one of the important part of the network. If the access network was not performing well enough, the services running in the network was would not have a better quality. So this type of network was also not deemed stable by the service providers, and they looked forward for an improved network. And so what they did now is they replaced all the switches in the access network with a router. Now it seems like all the problem has been solved. There are routers from access to core network, and a flat IP MPLS network has been extended all the way up to the access layer. What this has brought in the network was there was a substantial growth in layer 3 network. Uh, and for a moment, it seems like this was the perfect solution for the ISPs who are looking to deliver service in an IP MPLS network. But there were some underlying problems associated with it, even though the problem of broadcast and network reconvergence was solved with the third evolution. What were the problems? So the problem was because there was substantial growth in the layer 3 domain, the IGP domain became so large that the convergence time of the network was no more acceptable by the services run in the network. Uh, Not only that, whenever a service provider wanted to add any node for its requirement, it was not possible because adding the node would also add the increase the convergence time, which was already on its limit. So the network was no more scalable when this kind of topology was implemented. The network became large and quite unmanageable. And each network element, be it aggregation, core, or access, it acted as a main PE. So even the access router had to maintain all VPN routes, giving access routers a big burden that was not required for them. So what would be the solution to this problem? The problem of network evolution can be addressed by a technique called hierarchical VPN or HVPN. So HVPN comes into the picture here. So let's look at how HVPN solves the problem, underlying problem. Why cannot? Oh, I cannot move the slide back. Is there some problem? Let me directly go to the slide. I don't know why I cannot full screen this slide. Let me try one more time. Okay, I'll present with the same slide here. So the SVPN would be the solution to the underlying problems of network evolution 3. Now let's look at how SVPN or hierarchical VPN solves the problem. When we deploy SVPN, we isolate the IGP network of aggregation and access uh, separately. We isolate the aggregation and access layer as if they were a two different network. So when we do that, the IGP domain, the size of the IGP domain is limited, and the addition of any node in access domain will not affect the convergence and IGP domain size of aggregation network. This allows the network to be scalable. Any changes in the access network is now no longer protruded to the aggregation and core layer. Not only that, uh, because the access layer now cannot directly access the aggregation and core layer, the aggregation router that lies in the border of the aggregation access line has to provide the routes of the network to the access router. Uh, Now the interesting thing here is, because the access router cannot access all the aggregation and core routers where the traffic might be destined, special mechanism is required so that the access routers can forward traffic to aggregation and core node. The VPN deployment, when in this kind of VPN or isolated IGP, is hierarchical VPN. Now let's look at how SVPN works. Before that, let's delve into some of the basics on SVPN. Let me try if I can full screen the slide now. Oh, still I cannot. Sorry for that. So when we deploy SVPN, the PE devices or the provider edge devices can usually be classified into three categories. The P at the access end, or UPE, the P at the aggregation end, or SP, and the PE at the core network, which is called NPE. The SP, or the aggregation PE, has a crucial role to play when we try to deploy the SVPN. Uh, like previously described, because of the separate IGP domain, now the changes in the access layer is no longer protruded to the aggregation and core layer. So even if some accidental changes happen in the access layer, it does not affect the network of aggregation and core layer. Had it been a flat IP network, any changes in the access layer would also impact the aggregation and the core layer router's performance. Now the important part here, like previously, I tried to highlight the feature of SPE. What the SPE or aggregation router does is it stitches the VPN services from access to core. So because access routers cannot directly access the core routers or other aggregation routers, so what the SP router or the aggregation router does is it stitches the services coming from accesses and delivers it to related aggregation or the access or core. And one thing to consider here is, for the HVPN or hierarchical VPN, some other vendors like Cisco and Juniper, they refer the HVPN as carrier supporting carrier. So we should not get confused with the term HVPN, uh, because some vendors also refer to as carrier supporting carrier. So call it a carrier supporting carrier or is HVPN. They are same things. Now let's move to another slide. Now I think I can do the full screen. Now let's quickly look at the graphical difference between the flat IP MPLS topology and the HVPN IP MPLS topology. In the flat IP MPLS network, as the access layer has to carry all the routes coming from VPN routes coming from core and aggregation layer, the access layer router devices should be as capable as aggregation layer as well. Whereas on the right in the SVPN IP MPLS network, the access layer only needs to maintain the local routes, and they does not need to maintain all routes coming from core layer and aggregation layer. So the size of the access layer can be smaller in the network. So the capacity of the routers, the capacity of the routers in the access layer does not need to be as big as the capacity of the core layer or the aggregation layer routers. Now let's move forward with this. I would like to highlight some of the other benefits of hierarchical VPN. So apart from the benefit that I have just described, some of the other benefits would be, because the operation domain is separated by HVPN now, the aggregation or the vital network is now separated from access or the less critical network. When this separation is done, now higher level expertise can focus their time on aggregation network, and the junior team can look after the access network. This type of division in the network management has really become handy and convenient in the operation of an IP/MPLS transmission network. And like I have already described, the Ps in the access layer only have to maintain local routes, meaning we can deploy smaller routers in the access layer, thus saving the expenditure related with the deployment of the access network. And because of the separate IGP, the network is now scalable. And an important benefit of the SVPN is that though the operation domain is separated between aggregation and access, the aggregation network controls the services running from the access layers directly. Up until the aggregation network stitches the services coming from access layer, the configuration alone in the access network devices would not be sufficient to operate the services. So though the access layer are allowed to run independently, there are some kind of parental control done by aggregation layer before the traffic can pass to the core network. Now let's look at how we can configure the HVPN network. The configuration of HVPN network is similar to the configuration of normal IP/MPLS network, except that the access domain operate in separate IGP, and the aggregation router it operate in separate IGP. The BGP and the MPLS LSP are established in similar manner when IP/MPLS network, normal flat IP/MPLS network is configured. Now let's look at how L3 VPN works when we deploy the HVPN network. For this explanation, I have considered the example of how we are running the eNode B LTE service from the very start eNode B to its EPC core. For this, to run the L3 VPN in HVPN topology, we have created three different VRF, each in the access, aggregation, and the core router. So the LTE ACC VRF is created in access router, LTE AGG VRF is created in the aggregation router, and LTE core VRF is created in core router. Now, what the aggregation VRF does here is it just teaches the routes coming from the access VRF up to the core router, as well as it stitches the up to the access router, so that the routes from eNode B can reach to EPC core and vice versa. So for that, how do we achieve that stitching? We import and export the routes from the aggregation VRF, so that the EPC and eNode B can talk to each other. And an important thing to consider here is when we route, while routing from the aggregation to access, router, we have two choice. Either we advertise a default route, or we advertise the necessary aggregated route to the access router client. And for the operator who is running SVPN, the default route advertisement is most popular among them. Now let's move forward with how we can run L2 VPN in the HVPN network. The HVPLS or L2 VPN in HVPN network is as easy as the L3 VPN. So here as well, the aggregation router acts as a stitcher. So for this explanation, let's consider let's consider a FTTH client who is connected at the access router, and we have a BNG core connected at our core router. So to run the HPPLS, what we need to do is we need to create two PPLS service, one from access to aggregation and another from aggregation to core. And what the aggregation router needs to do here is it just needs to stitch the two BPLS together, BPLS instance together, so that the MAC addresses coming from the FTTH clients can reach up to the BNG core. Well, this HBPLS was also there in the normal IP MPLS network. It just comes into picture when we want to deploy the hub and spoke kind of BPLS. So the SBPN is as easy as the normal SBPLS. That was all about how we can run the services in a HPPN network. Now let's look at how we can manage and monitor the HPPN routers and router network. So as the separate as the aggregation and access now have a separate management domain, we require a management BRF in access layer so that the access layer devices can be accessed from aggregation and core network. And an important benefit of deploying uh, SVPN from a management point of view is that only one-time configuration is required at aggregation layer for each service. Any additional services and other configurations, the changes are required at access layer only. So the configuration for each service can be done just for a single time in the aggregation layer, while the access layer can independently add the service nodes on its own. Uh, uh, Now I have come to the final part of today's presentation. So before concluding today's presentation, I would like to share our experience of deploying the SVPN network, SVPN topology in our IP MPLS transmission backbone network. So before, we had a network of core routers and 250 aggregation nodes, which were routers as well, but 800 access nodes were switches. And because the access node was a big layer 2 network, we faced all kinds of problem that was described in the IP network evolution problems. We faced all kinds of broadcast issue, uplink congestion, and frequent reconvergence. For that, we decided to replace all the access switches with access routers, but that did not solve the problem alone because of the problems that were underlying in the network evolution 3. At that point, we decided to move on to HPPN to get the services to make our networks stable and to run the services as per our requirement. And we successfully implemented the HPPN topology with those number of access routers and aggregation nodes. And while we deployed that, we found that the configuration job was now significantly eased and distributed because the aggregation and access node were now different, and access node were handled by could now be handled by a junior team. The resources, the routers were efficiently used in the aggregation and access nodes. Now we no longer had big devices in the access nodes. We just had small MPLS routers in the access nodes. And because we had a separate OM for aggregation and access network, now we could allocate access network management of access network for the regional team, because if we have 10 access network, then we can allocate 10 different team to look after the access network, because the access network were itself isolated from other access network as well. So yeah, that was the experience that we had with deploying HPPN. Now I would like to conclude today's presentation by highlighting some of the features of HPPN that would come handy to the service provider. What HPPN does is it leverages or enables the service provider to efficiently utilize the network elements or the routers. The higher capacity routers can be deployed at the core and aggregation layer, whereas only lower capacity routers are required at access layer. The management of the core or aggregation network and access network is separated, allowing the service provider to allowing the service provider's expert team to focus on aggregation network, as well as the new or junior team to look after the access network. The configuration and operation of overall network was made easier when HPPN was deployed. And the last and the most important thing from the service provider's point of view is the capital expenditure and operational expenditure of the access network was hugely reduced when SPPN was deployed in the network. Yes, that was all I have to say for today's presentation. Thank you very much for listening and for your kind attention. Now, I would be happy to answer any of the questions from the audience. Thank you very much.
Thank you very much, Subin, for that interesting presentation. So I don't see any questions there, and besides, we're a little bit out of time here. So if anyone has any questions, please reach out to Subin directly. His contact details should be in his slides. They'll be put up on the website. So we'll move on here with the next presentation, which is on IETF network slicing, and that'll be delivered by Dhruv Dodi. He's the chief architect for standards at Huawei in India. And he does a lot of work in the IETF, and among other things, he's a co-chair of the PC working group. So Dhruv, thank you very much, and it's over to you. I think you may be muted there. You're on mute there, Dhruv.
I hope you can hear me now.
Yes, we can. Thank you.
Okay. Hi, everyone. So let's talk about network slicing and the work that has been started in the IETF. And thanks, Paresh, for the introduction. You guys can read that later, but the part that I wanted to highlight was that you might have seen me posting on the SANOG list on behalf of IISOG, bringing in some of the things that we are doing about how we can increase the participation from our region, from SANOG region into IETF, and we have been approaching it via various ways. So you see some of the emails. So we would hope that more operator community come and help us in increasing the concerns from this region into the standards bodies. So let's begin the talk. Just to set the scene, I think we have all heard of 5G. 5G has been in news, good and bad, lots of controversies, but we will be focusing mostly on the technical aspects, especially where the IETF comes in. So 5G, as the name stands, is the 5th generation of the cellular network. You have seen, we have all lived through it, from the first mobile phones that we had and the services that we had back then, to what we can do now with 4G and 4.5G, and what the future hold with respect to 5G. The vision of the 5G basically is a network that can connect everyone and everything. So it is one which is built for IoT from the start, and as well as very innovative services. So we will talk about what are those innovative services and what would be the impact of those services on the underlying network, and how the underlying network can cope with these services. So that would be the main crux of today's talk. Okay. 1 second, did I just, yeah, it's fine. So what is the key 5G use case? If you read the 5G documentation, they always talk about these three different types of services that makes this 5G triangle. The first one on the top is basically an enhanced mobile broadband, where you have like what we already have as a broadband, but how we can enhance it with 8K video services, AR, VR, things that we can do at home to get better, better gaming experience, more bandwidth for our user. That's the main thing. So enhanced mobile broadband, that would be the key use case. The second one is for ultra reliable low latency communication. So as the name stands, it's we need to make sure that's super reliable and the latency is very low. And this would be used for mission critical communications. Of course, the cars comes into the play, and of course, if any robotic and industrial use cases, even hospitalization, all that stuff where you need to make sure that the reliability, security, latency is our top-notch requirement. And the third point in this triangle is what's called massive machine type communication. And again, this is basically the IoT based communication. You would have endpoints that are low cost, have low battery life, would be massive in numbers, but would be sending very less amount of data as compared to, say, the video services that we were talking about in EMBB. So basically, three, as we can say, our use cases are so disparate and so different from each other, but that's the beauty of 5G, that how we can provide all these different services using the same infrastructure, same mobile infrastructure end to end. So that's where the beauty of 5G comes in, and that's where all these interesting use cases that we keep hearing in the media comes in. So this will show you how different the requirements are. Let's break down the requirements of these three different types of use cases. For IoT use cases, the coverage is the key important. Energy saving is very important. Make sure that the complexity is low, because of the scale. We have very small devices, so they cannot have too much complexity. The density question, that's where and they don't care about the latency part and the mobility part as much. And when we look at, say, the mission critical system, ultra reliable system, here the low latency, reliability, security is the one which is driving the requirements, and they may not care too much about the complexity part or the the coverage part per se. And for broadband, again, the capacity and the data rates and discovery and optimization, those are the key requirements. So what this is highlighting is look, we have all these different requirements. Each 5G use cases might be asking for something else. So how do we achieve it? That's where network slicing comes in. So network slicing is one of the key enablers in 5G networks, that how we can have these different service requirements being fulfilled by the same network. So what do we need to do? We need to have some kind of virtualization and independent logical networks on the same physical network infrastructure to meet these diversified service requirement. When you just read this, you said, oh, we have been doing this already. We just had a talk on VPN, and isn't VPN something like this? In some way it is, but what are the missing characteristics in VPN? That's where the ITF is coming in and see okay, yes, VPN is one of the key building blocks, but what is missing? Let's try to add so that we can get these use cases of 5G use cases satisfied, maybe even by enhancing VPNs in some way. So what are the key requirements for network slice as compared to any other virtual network? The isolation of an end-to-end network is the main characteristics. As we see that 5G networks will move from your air interfaces from eNode Bs to your mobile core and edge core and then data center, and you need to make sure that your reliability and your latency not just in one isolated part of the network. And that's where if you think of VPN, the VPNs are just part of our service provider network. We only can control maybe the MPLS IP core network that we have, little bit on optical side if we are doing IP MPLS, IP optical synergy, but we have no control over the other parts of the network. So how can we have the 5G use cases that we were just talking about if we have control only of a part of the network? So end-to-end network becomes a very key requirement. Isolation becomes a key requirement in the sense we would not have just one slice or one type of slice. We talked about 3 different use cases, but now also think about how many number of slices we need to customers. Each of the customer may require a separate set of slice. So number of slice and impact of one slice on another slice becomes very important. That's where the isolation word comes in. So network slice needs to be isolated, needs to be end to end, needs to be tailored. We cannot have like just 3 types of service like gold, silver, and bronze. No, we need to tailor it to the requirement of each of the network slice. So that tailoring becomes very important, and need to support diverse requirements requested by particular application. And again, it's not just about meeting them. We need to make sure of the life cycle of it, the creation, deletion, monitoring, automation, all that part comes in. So let's go a little bit deeper in each of them as I progress. So network slicing, what would it do? It will enable the most economical model to provide this service differentiation and meeting end user SLA. So slicing is the technique to make this easier to do. There are a lot more ways to divide your network. We all have been doing it, but network slicing is the technique that would make it economical to do. That's the key thing. And it uses a lot of things which are already existing. It's not something which is brand new. We have been hearing about SDN, network function virtualization, orchestration, telemetry, closed loop automation, all the things that comes in when you are operating the network, all the new techniques. So basically the slicing is building on these building blocks to achieve this requirement. So this was just to give you a little bit background of the work. And now I will start maybe focusing on where the ITF comes in. And some of the networking background, basically, where did we started from? We know that ITF has been standardizing this for a while. We talked about something that has been well deployed and operated, which is the VPNs. So that's our starting point. VPN started with, yes, I can provide you a very simple service, which is focused on connectivity. These are your customer sites. I want these sites to be connected so that they behave as a virtual network, whether it at the L2 layer or at L3 layer, VPLS, EVPN, all that stuff comes in here. We also have a support of traffic engineering. Traffic engineering is not new. Within the service provider network, the way to traffic engineering, we had all the tunneling techniques, segment routing is something which is coming up. So we have been doing this for a while. But let's go over the concept so that we can apply the same when we are talking about the definition of ITF network slicing. So some of the concepts that are well there, we have the idea of abstraction. Since you don't have just one network, you have so many networks, managing the network, you need to do some kind of abstraction. You need to start hiding some kind of information from run domain and doing operation at an abstraction level. This is something that we know how to do. Virtualization, again, having a virtual network, VPN is just type of one virtual network. Anybody who works on data center will know how to divide the networks, virtual network. We do, even our VLANs are a type of virtual network. So yes, we know virtualization. They have been focused on what? Connectivity. But when you add traffic engineering to it, it's not just connectivity, but we would have connectivity with some qualities. So let's break down what are the various ways we do this. We can just ask for connectivity. We can ask for enhanced connectivity. That is, maybe if I enable my VPNs and also set a different per site bandwidth, that's one option. We can also let customer manage it. That's where managed and operator connectivity comes in. Carriers, as was earlier talked by Subin in his talk, as well as an example. And IP over optical, again, IP network controlling optical network. So we've been doing this. So now let's see how we are enhancing these networking concept to meet the definition of network slicing. So the first bullet point, we need to make sure that we have multiple virtualized and independent networks on the same shared physical infrastructure, with each slice tailored to full diverse requirement. So in our world, sharing is very important. We are not talking about dedicated networks. We are not talking about partitioning the network completely. We are talking about a virtualized and logical network over a shared physical media. But to do that, to meet the diverse requirements, you need to start partitioning the resources as well. So the resources could be we know this, how to do this, VPNs do that, but not just with respect to connectivity. Look, we start looking at bandwidth as well. So that's where RSVPT can come in, SDN can come in, which can help you manage the network resources as well and associate this particular resources to a particular slice. This can be best effort. This has to be service guarantee, especially when we were talking about some of the use cases which require ultra reliability, ultra low latency. You need to do this in a guaranteed way. So the guarantee could be for latency, it could be for jitter, it could be throughput, so various different things. Not just partitioning, we need to reserve. So again, guarantee and reserves go hand in hand a little bit. So what can you reserve? You can reserve some bandwidth, you can receive some, if you're doing NFV kind of system, so you need to reserve some compute power, all that stuff. Isolation, again, since we have multiple slices, we need to make sure the impact of one slice over the other is low. So that, what kind of impact are we talking about? The impact could be in terms of performance, of impact of one's traffic on another slice traffic, security, privacy, management, all that comes in. So isolation is much beyond the, like, just the performance thing that sort of comes up in our mind when we talk about isolation. And then you need to make sure that this whole thing is controlled and orchestrated in an end-to-end manner, and it needs to support multiple domains. So again, the SDN and the orchestration principle comes in. We can't do this manually because of the scale that we are talking about. This needs to be orchestrated in an automated way as well. So a pictorial diagram to show, like, when 5G people in 3GPP talk about network slicing, they are usually talking about, say, the whole end-to-end network slicing. And this require a lot of work in the RAN slide. So that's where your edge slice comes in, as well as some work inside your core. And even data centers are involved. So the core slice, the edge slice, and then this is our service provider network in between. That's what we, like, in the ITF world, we call it the ITF scope network. So our focus in the ITF is how to achieve this ITF network slicing. But the key use case for ITF network slicing remains to be 5G. And that's why, like, this is very important to understand in the industry, that within the ITF, we are only talking about a very limited set, but this will work within a concept of an end-to-end network slice. So again, an example, maybe, like, an ultra reliable system asking for a slice which goes to, like, the core. You may have some video bandwidth requirements. So this might be the EMBB, so all that stuff. So different slices, end to end. These are your network slice, but within the ITF scope network, they are just an ITF network slice with different requirements, meeting different criteria. So how do we think of, like, the definition of an ITF network slice? So ITF defines this network slice as a logical network topology connecting a number of endpoints with a set of shared or dedicated network resources that satisfy a particular SLO. I will talk about, like, what is SLO and how it differs from SLA, etc. in the next slide, but bear with me. So the main thing that we did was, this is not the definition of the 5G network slice. This is the definition of an ITF network slice. So we only care about logical stuffs. So we are saying that we need to create a network topology. You need to tell us what are the endpoints, and you tell us what is your service requirements, and we will provide you the connectivity with this set of service requirement. When we initially had, if you were involved, the name actually was transport network slice. But, like, ITF, we have transport area, transport protocol, lots of confusion with what exactly means to be transport in ITF. So basically the conclusion was, let's call it ITF network slicing. So, but these kind of debates are very interesting to follow as well. So as I said, 5G is still the key use case, but the concept of an ITF network slice can actually be used for anywhere where we need to have logical separated networks for NFV, for data center interconnect, sharing network infrastructure among multiple operators, the carriers of carrier kind of case, network wholesale services. So a bunch of different use cases you can build, because at the end, what we will provide is just an API that within the ITF scope network provide this network slice from these endpoints and these service. So anybody who wants to use that API can build new use cases. So this is not limited just to 5G, but can also be used by any of the use cases that you in the operator community can come up with. and vendors will try to innovate to meet those requirements. The ITF focused on that we definitely don't want this to be technology specific. We are not saying that you need to have segment routing or RSVPT, or these days even DetNet is quite coming up with when the deterministic latency requirements are coming in. But they are completely technology agnostic. At least the logical network requirement should be not tied to any particular technology or any type of layer. It should be logical and independent of the underlying infrastructure connectivity. So again, we are not talking about like, whether it's an L2 VPN, L3 VPN, EVPN, SRT, SRv6, doesn't matter. This should be independent of that. So I will try to talk about it, that how ITF visions that how to do this, to meet that requirement. We need to make sure that multiple set of applications can coexist. And slice basically refers to a set of characteristics and behaviors that separates one type of user traffic from another. This is another good definition, which I like, which is in the last thing. If you look from not from how you are achieving the slice, as in the requirement of the slice itself, but what is the impact of the slice. Basically, you are separating whatever the user data that is coming in, identifying, oh, it should belong to this particular slice. It needs to get this kind of behavior and treatment within my network. So let me make that happen easily. So let's now talk about the SLO stuff. So we need to have a very clear requirement of what is the slice service requirement. It needs to be quantifiable. So you need to give us something that is easy to measure. That's where the quantifiable things comes in. And the key thing would be, what are you quantifying? What is your indicator? That's the SLI. So whether it is, say, the latency or throughput or bandwidth, anything that is the indicator that tells me how my network is performing. So what is the thing that you are measuring is the SLI. What are you measuring against? That is, what is the target value or the range that is acceptable to you is the SLO. And basically, as we saw in the initial definition, a slice is basically endpoints plus set of SLOs. So these are my endpoints, and these are the service level objectives. That is, throughput must be this, latency must never go down less than 10 milliseconds. So those are my objective. And again, we are not talking in terms of how to achieve those objectives, but just these are the objectives. You determine the underlay technology you are going to use to meet that objective. That's up to you. This is still only how. And in fact, in ITF and in industry, you must be hearing the word intent. So that's basically where this thing also comes in. And in ITF, this is right now currently a research group, but a lot of things is in the industry, you keep hearing, and this has become a hot topic as well. SLO could be directly measurable or indirectly calculated. That's completely fine, but it should be something that is quantifiable. That's the main thing. And SLA, I think that's a very well-known term. Like, this is basically an agreement between the consumer and the provider, where you would make it up of multiple SLOs or whatever the contract that you have signed at the sort of more at the management layer rather than in the layer that we are in. Very interesting debate whether isolation should be considered as SLO. Basically, can you quantify isolation? So this is a very interesting debate that's been happening. People are saying maybe we need to break it down into each of the different isolation thing, and other people saying no, isolation is sort of either you have it or you don't have it. If you need to quantify isolation, you need to put it as other SLIs. It cannot be isolation on its own an SLI. So very interesting debate. This debate is not yet settled. This work is still in progress, but quite interesting debate nevertheless. To do this, we talked about service requirement. The other thing is endpoints. You need to have a logical idea of what your endpoints are. Endpoints could be CE, PE, link addresses, whatever way people want to have. So again, from the ITF point of view, this is logical, but somehow there should be an agreement between how these logical entities map to your actual devices inside your network. And the connectivity requirement could be simple P2P, P2MP, multipoint to multipoint, hub and spoke, full mesh, all that different things that's possible. So framework that we have is basically, this is how we're going to achieve it. So in ITF, we assume that we have like a top level controller. We call it IETF network slice controller. Again, this is a logical entity. It's not a physical controller that ITF is talking about. It's just saying that these are the set of functionality that this guy needs to provide. And this guy can be implemented in an existing orchestrator. It could be your SDN controller, wherever this functionality is placed. But basically, the job of this guy is to do the whole lifecycle management, the creation, modification, monitoring, deletion of your network slices, and mapping the northbound interface. That is, what is the high level requirement from maybe an end-to-end network slice or an orchestrator, mapping those requirements into my network controllers, right? So how do I, maybe in my network, I'm using SR system. So, okay, what is the SDN API that I will use for segment routing to enable, or whether I will use PSAP. I belong to PC working group. PSAP as an SBI is quite popular as well. So his job is map the intent requirement that is coming from the higher level system into exactly how to realize network slice into your controller. But again, the scope is limited to ITF network. You would have separate controllers in the 5G world, like RAN slice controller, which will try to do the similar thing on a RAN network, and how to slice an air network, which is very, very different from how to do this in IP MPLS network. And similarly, a core slice controller might be separate, which might be doing this in a data center world, either using NFV orchestration and MVNO, etc. So the quality of a proposed NBI is, it needs, as I said, it needs to be agnostic. It needs to have, identify the endpoints clearly, tell what the connectivity is, what are my SLOs. But another key thing now is coming is, it needs to have a good idea of how do I monitor. And again, like, because what we are used to in our current network is monitoring at a very, very low level. But since your requirement is coming at a very high level in terms of a slice, you need to provide interfaces to monitor the slice itself rather than a particular service at a particular node. So how to do this end-to-end monitoring, that's also a very interesting thing that we need to follow. And that's where the controller will play some role, that how he collects data from our network devices and network controllers and convert into something that's should be exposed outside your network using this NBI. Okay, so I'm a little bit less on time, but what I will focus is just a idea of, now we are moving to, we understood what the network slice is, but how do we realize the slice? And ITF has been working on these different building blocks for the long time. You guys are well aware of at least this part, like SDN, VPNs. DetNet is a new working group talking about deterministic networking. They are changing things in data plane in IP and MPLS. SRv6 is a very interesting topic. In fact, there is a tutorial, I believe, by Paresh himself. So that would be interesting. So these techniques exist. The idea is, how do we build on these techniques to meet the requirements? And that's where some of the well-known interfaces in ITF is, one is ACTN. It's called Abstraction and Control of Traffic Engineering Networks, and also Enhanced VPN. I will just do a 1-minute introduction to both to just give you an idea of what these frameworks already exist and how we need to build on these to achieve the slicing requirement. And Yang model in ITF is anyway quite, a lot of work has been going on with this modeling technique, and netconf and restconf have become quite popular when it comes to talking between orchestrator and controller. So all the interfaces that we talk in terms of NBI and all were Yang based, and Yang is a proper technique, a popular technique to be used there. This is ACTN. This is already an RFC 8453. This, in fact, came before network slicing became popular. But this idea of a virtual network, as I said, is like, is quite old. It reaches around 75% of the requirement that network slice had. Where it failed was, this was not technology agnostic. This was still very tightly coupled to traffic engineering concept. It's difficult to use segment routing here. So there were some issues. So this was not very technology agnostic, but the concept was very much similar. We need to have virtual networks. There are multiple separate domains. You might have domain controllers. You need to have like a multi-domain service coordinator. You have various different requirements that are coming from customers, which are sort of like a slice requirement. they need to be supported within my same network. A lot of things are the same, but that's why ACTN is now a building block over which we are going to achieve this requirement. This is enhanced VPN. It's built on, like, we know VPN, but what if we have VPN service that could guarantee network resources and predictable performance? And how would we do that? Oh, you need to have some tighter coordination between the overlay and underlay. Like, you cannot just assume that, oh, I'm here only for connectivity and I don't care whether my underlying network is working. So to do that, they have a new concept called virtual transport network, called VTN, which is a customized network topology which is tightly coupling underlay and overlay. So this is a tight coupling of an underlay and overlay. And again, it again builds on ACTN, but focusing only on the VPN side and how we can do this kind of integration. So a lot of work. This is again something very new. This has not been standardized. This is not an RFC yet. A lot more work needs to be done in this place as well. But I just wanted to give you an idea that yes, this area, a lot of things are coming in. People have a lot of different ideas on how to realize this network. Yeah, there is, like, SR, can we enhance segment routing to do this? There's a concept of, can we add resource awareness to our segment routing sets? Can this be, since SRv6 provides you a lot more way to network program, can I add some slice ID? Can I use things like multi-topology and flex algo in my IGP to do it? Can my SR policy can do it? Lots of different things. Various vendors have come up with lots of different approach. ITF has not finalized any of these. This is still work in progress. But if this is something that interested you, so join the ITFT's working group. And as an operator, like, 5G is going to be a quite an important work. So it's important to get involved, at least at the initial stages itself, so that you have some say in how this work is being done. And that's my slide. I have 2 questions. Do I have time to answer these questions?
Yeah, Dhruv, I mean, if you could do this in 2 minutes, then I think we can do that. And if it's beyond that, maybe you can respond on the chat window or the Q&A window.
Yeah,
So,
I'll do that. So let me take the first question, which is about end-to-end network tailoring. So I think in my mind, the end-to-end network tailoring and end-to-end network slice, they are sort of the same concept. You are the slices. The thing is, where this comes in is, like, most of the operator have some predefined slices. And what that predefined slices is, that's sort of like how we have gold and silver and bronze services. So these are the only slice that I will set up. And all the customer requirements needs to be mapped into these existing templates of a slice. That's mine, where you are not customizing your slice too much. But in 5G use cases, that's not going to fly. That's what we have been doing already. That's that tailoring concept. Like, you have some VPNs, you just map all, whatever is the requirement from the customer, it goes maps to the same sort of VPN. But no, that's not going to work. You have such different requirements that they need to be tailored for each slice requirement separately. And that's why a new way to do this is required, and we are not able to realize what's already existing in our system. The second question was, who will own the end-to-end network slice orchestrator? Very good question. So let me just take that one. So this is like, if you look at 3GPP architecture, the idea would be that this is basically the mobile network owner. This is sort of your customer. This is the guy who's just providing you connectivity. He's not the owner of this end-to-end network slice. So your mobile network, who is owning the edge and the core services. This is where you're, like, you're even in LTE terms, if you look at eNode B, and this is where your UPF and other things would be there. So you are providing connectivity between them. So that's where the ITF is coming in. But this guy is the one which is your mobile network, which needs to do the billing, there's that, all that stuff when it comes to the network. So basically, customer, if that's your question, service provider customer, it's the customer. And for end-to-end network slicing from radio to core, how ITF will be synchronized with core and radio. If ITF is a service provider and core, yes. So the synchronization is a very key thing. So what is the part that needs to happen at the edge in the data plane? This work ITF is currently not doing, but this is going to be an interesting thing of how the handover happens. So 3GPP, like, for instance, they believe in, like, if you look at their architecture, they say, oh, we have these GTP tunnels which are going to run. So for them, this is just a tunneling. They don't really care what is the way, like, on network on which. So some people are talking about SRv6. A lot of work is happening, like, so that SRv6 allow you to do network programming a little bit. So it's easier to map the slice requirement to this. So there is some handoff that's going to happen when you leave the edge network and enter in data plane. Similarly, from here to here, that will depend a lot more on what this thing is. And there are new concepts. There is something called even application aware networking, which has been, so a lot of new things are happening. This is not yet finalized, but at a very high level, these things believe that I have a GTP tunnel. I don't care. The tunneling should take care. I don't bother what's actually technology that is happening here. But when we talk about requirements, the idea is that's why these controllers are going to be very important, because they need to monitor things end to end. The job of the ITF controller would be to share how the service is running within his network. And if there is some information that I need to pass on to the end-to-end system as well, and the telemetry that you will be connecting would be from edge, from core, from various places, and then try to figure out, oh, what's happening within my network. But to answer your higher level question, the owner of this slice is still not the provider, but the customer itself. Hope I answered your question. If I didn't, just send me a chat or ask the question here, and I will try to answer by text. And I'm above my time, so I'll stop talking now.
Excellent. Thank you very much, Drew, for that very interesting presentation. So that brings us to the end of the second plenary session, and I believe we'll be coming back in about 7-8 minutes time, right? Philip, someone?
Yeah, let's take a 10-minute break, because, you know, just for folks who need to stretch their legs and arms and back or whatever else. So we'll start, I would say about 10 minutes or so.
Excellent, thank you.
So if the speakers for the next session, please, if you can get yourselves ready, the Zoom hosts will promote you up into the session shortly. So that's Bijal, Sharafzal, and Marco. What we should try and do is check and make sure that your Zoom works, so we don't repeat the problems that we had in the opening plenary and the first of the technical sessions. Maybe I should actually turn on my video rather than hiding here. Let's have some video. There's a huge thunderstorm going on outside here, which is very alarming, because that usually means my internet stops working. So just a heads up for, well, other folks who are running the session. If I disappear, I'll try and get back as quickly as I can. But just so you know, if I actually vanish. So
okay.
Marco or Bijal or Sharafzal, do you want to just try sharing your slides just quickly, just to make sure? I see you both, so that's a good start, which was more than we had for a while and Champ earlier on today. Yeah, look at that. Perfect.
Yeah.
Happy New Year, guys, by the way, in person.
Thank you. Better than by email, yes.
Okay, so I'm all good, I think. Hi,
You're
Happy
all
New
set,
Year, by the way.
Yeah.
So wait.
Yeah.
Once.
Yeah.
Okay. Let me share my screen. I think this one. Oops. Can you see it? I think.
Look at that. Looks very good. Yep. Perfect.
And you see even my reminders, if I'm not wrong. I'll stop.
I don't see any reminders now.
Okay,
no.
good. You see
looks
it.
Good.
Yep. Perfect. So let's close it. Stop.
And Sheriff Zell, you're there as well. Do you want to try sharing your screen?
Yeah. Hello, everyone.
Hey, there you are.
Yes. Let me share my one.
Well, the fact that we can see you is a huge positive because we couldn't do any of this earlier. Look at that. Excellent.
Did you have some teething problems this morning?
We did. We were not using the cloud. There's actually a local Zoom instance in Kathmandu, and NREN's Zoom, of course, chooses that one.
Yeah.
And what we found is, as the email I sent to all the speakers, is that 549 clients could not see presentations coming from some people. And we thought it was older client versions, but then Awal did his RPKI presentation. He's on 549 and none of us could see him either. It was only those who are on the latest client. So people on the older one had no issue.
Oh, sugar, because I actually upgraded, so hopefully I won't have any issues.
No, we're all fine now. So what we did during lunch, what we did in the Kathmandu lunch break was we used a cloud instance. So NREN selected Singapore, and we're now in Sweden. Don't ask. We're in Sweden.
It works.
Well, you can check what your client says, but we're apparently now in Sweden. So, so Zoom has decided. Anyway, so we'll wait about 5 minutes or so, and then we'll get going because it's.
How is latency then to Australia from Sweden?
I don't know. I mean,
so it works, obviously.
It works. 350 milliseconds is what I experience normally. So, but it seems to be here, and nobody is making any comments that they're not able to see the presentations. The quality has been substantially better. So, yeah, I think we're good now.
Good.
So I think we will rejoin after a short break.
Yes. Yeah. Yeah. Let me see who's up first. Yeah, Bijal first, and then you, Sheriff Zal, and then Marco finishes off. So, and that should be fine. So we'll start in about 5 minutes. Just because we overran about 5 minutes and we started late after lunch. Our long lunch became a very short lunch because of some of the problems this morning. So that's why it's a little bit late, but we've sorted ourselves out now. So all is good.
Yeah, good. It always happens when the first I think half an hour is just so stressful, isn't it? Until things start going. And then even at physical meetings, like when we do the URXs, the first morning is just like a complete trying to make sure everything's running on time, and it's just a bit of a goat's rodeo really. But then after the first break, everything just slips into place and it's all fine. It's
And and the funny thing is, this is not the first time that many of us have done this, but it still felt like the first time. And it's like, what has Zoom done to us now? It's
trying to keep us on our toes.
Yeah, and I'm watching this from an apricot point of view, an apricot perspective, and it's like, oh gosh, what's going to happen? And there's like a software update, and so forth. It's just all these. I don't know, people talk about unknown unknowns, but this was definitely an unknown unknown.
Yeah. Are you going to be using Zoom for Apricot as well?
Yes.
Yeah.
Yes. So APNIC is hosting Zoom for Apricot. So there are 2 parallel webinars, and there'll be some of the sessions I think we're going to have to use Zoom conference. But as far as I'm aware, that's going to be the Singapore data center. So fingers crossed, it will all be okay.
Yeah.
It's just more a case of like those of us who are chairing sessions will have to work out where we go, at least those of us here in Australia, because the broadband is actually pretty poor. So, my one goes off when it rains, and it's an absolute, I don't know if you can see, it's an absolute deluge at the moment. I still have internet, so I don't know how. So, there's just all these things, and it's, I mean, I know this is still live that everybody can listen to it, but you know, it's like at I think it was it MN Mongolia Nog late last year. So Jared was talking about the fiber he built his home because he couldn't get good fiber.
Oh yes,
and his internet went down. That was so hilarious. It was just one of those things. So no matter the best made
Perfect
plans,
timing.
something will happen. So that annoys.
Many people at the meeting.
Yeah, we had about 600 registrations. And for the first two sessions, we had about, the opening plenary, there was about 170. And then the second session, it dropped back a bit to about 150. And then we had to restart the Zoom session after lunch because we had to move data centers. And so we've had about 80 or 90 or thereabouts, which is kind of what we expected.
That's not bad.
Well, it's the usual thing with any of these. It's very easy to register for a free online event, but actually coming to it is a different matter. And we're talking more about this. I mean, it'll be too early for both of you, but the panel session tomorrow morning, the South Asia NOGs will be talking about the challenges they've had putting events together, like getting presentations and running these virtual events, which is it sounds simple, but it's a challenge you had with SANOG.
Yeah.
We had more submissions in the week running up to the presentation closure than we had in the entire 2 months that the call for papers was open, and we're sitting with exactly the same thing for Apricot. It's like the number of submissions is very limited, and we ask people and they say, oh, but Apricot's not until the 1st of March. And it's like, well, yes, but program committee is trying to put a program together. What's all the rush about?
I think everybody's so fed up of virtual events in the meantime. Somehow.
Well, you're right, and I shouldn't be saying this on a live thing, but I think it'll come out tomorrow in the panel discussion. Is the Apricot program committee is saying similar things. There's so many of these virtual events, and people are just kind of over it in some sense.
Although I have to say, big thanks for putting this together, because I stood up at 4:30 just to see the first session, and already the first session was very interesting to me. So it was good. Yeah. It paid off at least. It's the first virtual event for ages which I attended, because I really stopped doing it. I was so upset seeing people only on the screen and not live.
It is very difficult, and we've had a few discussions in Apricot PC in that way as well. Probably less so on the SANOG one, but more on Apricot PC about it'd be really good just to be able to meet people in person again.
Yeah.
It will feel like the first time we do it after such a long time.
Yeah,
I know.
Exactly.
It's gonna be really weird.
Anyway,
but at least we know everyone's living room now.
We do. We do. Everybody's working at home space, and doing virtual backdrops, and I'm being reminded, Philip, get a green screen behind here because nobody wants to see your garden or the shelves of stuff or whatever else. But I don't know. Then you see people on all different virtual backdrops, and I was in a conference yesterday with all kinds of different virtual backdrops, and some were playing music, and then it just got so distracting for the whole thing. So. By the way, the rest of the attendees, sorry to bore you all with our chit chat. We'll be talking about all this in the panel session tomorrow. I'm sure it's going to be discussed in some of these.
Yeah, I might actually join for that, because it's I think it'll be interesting, because I when you think about travel now, I mean, I'm based in the UK, and we obviously have a couple of vaccines, and they're trying to roll them out as quick as possible, but I don't know if we're going to travel this year, to be honest.
No.
Yeah.
And and just before we start, that's what Australia's chief health officer has basically said. to all Australians, forget about any travel for 2021 and even well into 2022, which is, okay, that's topic for another time.
Yes.
But, it can be a topic for the panel discussion tomorrow. Philip Pepys, who's chairing it? Yes, Philip Pepys, please make notes. Anyway, I'm being reminded that we need to get started.
Before you start, just a quick question before you start. All the papers are ready in the submission system for this session?
Yeah, Bijal, Marco, did you have any final tweaks to your slides? Otherwise, we'll just use what's in the paper submission system.
Oh, sorry, no, I do.
Okay.
Yes, I will. I'll send them over to you straight after. But I have updated slides.
Yeah, Marco?
I only added the IXP update to the end of my presentation, but I think you don't need to. It's just for now for this presentation. Sure. But rest stayed same, I think.
Yeah. And Sharafsal, did you have any updates to your slides?
Yeah, of course. I mentioned on that we are going to install the Google Cache on that time, but right now it's up and operational. So I have updated that one in my slides.
Right. So if you could send them to me, it's probably easiest, and the updates,
So
then I can forward them.
Oh, okay. Just asking, do you want me to update the site with the existing one and then replace with the updated one, or should we wait for the updated ones?
Let's just wait for the updated ones. Otherwise, if people follow through, it will be confusing. So
thank you.
I think that's
done.
Okay, I will just send it to you right now.
Yes, thank you.
Yeah, thank you.
All right. Sorry about the delay in starting. I thought we'd give a little bit of a break for folks just to go and stretch the legs. So welcome back to the final session of the day for SANOG 36 virtual conference, kindly hosted by the Nepalese internet community. First up, we have Bijal from EuroIX, who's going to give us an update about the IXP DB. Bijal, it's all yours.
Thank you, Philip. Hello, everyone. It's lovely to be here. Of course, I would, we've just been talking about virtual events, and I hope that we can all meet again and have these conversations face to face. But in the meantime, I'm going to present to you about the IXP database. So before I start, I just want to let you know a little bit about EuroIX. EuroIX is a membership-based association. We currently have 72 members, IXP members, and they're not just based in Europe, they're from all over the world. And we actually have some which are based in the South Asia as well. So today I'm going to talk about the database. You may have heard of the IXP database. It's been around for over 15 years. EuroIX is actually celebrating 20 years this year. So the database has been around for over 15 years. And as a membership-based association, we spoke to, we actually surveyed the EuroIX members and said, okay, what is it you need out of a database? And what they found was that existing databases didn't allow them to publish their accurate and full data set. So many databases were there which had administrators that were doing the work. So the IXPs didn't have, if you like, control of their own data. In 2016, the IXF members, which is FIX, which represents Africa, APIX, which represents Asia, and EuroIX from Europe, and then LACIX representing the South America and the Caribbean. We agreed to build a global IXP database. And one of the key things we wanted to do here was we wanted to introduce automation and make sure that so that we could have top quality data. And then we introduced the IXF JSON schema. The IXF JSON schema, and I'm going to go through the links at the end of the presentation. But before I do that, I just want to show you some of the features that you see from the IXP database. So on the homepage, we actually just publish the statistics and aggregated data. So we're currently collecting data from 256 IXPs automatically. They all export an API to us, and that is obviously stored in the database. And then we are in the process of actually creating more tools that can be used for both networks and IXPs. So very quickly on the homepage, obviously you can log in and see this yourself. But what we see is newest IXPs that are entered into the database. You can see IXPs by connected ASN. So if you want to see over here, you can see the number of networks that are connected to the IXPs. So we see here Sao Paulo in Brazil has 2,153 networks connected. And then we have DKIX in Frankfurt with 1,028, and then so forth. You can also see on the homepage the networks and also unique networks that are present in the regions. And we do this by looking at the ASNs that are present at the IXPs and seeing which ASNs are only found in a particular IXP and then region. Obviously, we're going to be breaking this down later on into city and then countries, but at the moment we only have the regional data. So for example, if we look at Asia, what we see from the IXPs in Asia is that there are 4,588 networks present, and out of those, 1,656 are unique. So what that means is that 1,656 of those networks are only going to be available via peering in Asia. We do drill down to the IXP level, and I'll show you that shortly. Also on the homepage is we look at the IXP the switches and the network switches, and we do this because the JSON also sends us the MAC addresses, so we can convert the MAC addresses into the vendors, and we can see the number or a rough idea we can get of the different vendors that are being used at both the IXP, which is the IXP switch hardware, and which vendors are being used at the networks, which is the IXP. Sorry, that should say network hardware, not switch hardware. Typo, sorry. Also on the homepage, you see the latest connection. So you see the latest, and remember, this is all done automatically through the API. So as soon as there is a new network that's joined an IXP, you can see it straight away. You can see I updated the presentation on Friday. So you see there was a couple of new networks that joined IXPs on Friday. And then, of course, traffic. We also are about to release a new traffic standard JSON schema, and IXPs can use that to publish their traffic statistics to us as well. So one of the other features that you can see on so when you go down into the IXP directory, you can actually drill down and get further information about internet exchanges as well. You can search for exchanges. Which only have an API, because we do have IXPs in the database that don't export their data, and you can see very clearly the ones with the ticks where you see the APIs, the ones that automatically send that data to us. You can also search with IXPs that share traffic. So if you're just interested in looking at traffic, you can see which IXPs are sending us traffic, and also by region. So over here, I've selected Asia, and you can see the different, obviously the list is longer than this, but you get a rough idea of the IXPs there. When you the other thing that we can do here is we can actually compare IXPs. So what you can do is you can click on any IXPs that you want to compare, and then you hit compare here, and you can actually look at, you can actually compare the IXPs. Now, why would you want to do that? So you can, for networks that are looking to join IXPs, they can use this as a very quick snapshot. Like, okay, let me see, I've used DKIX, I've used 2 in Mumbai here as an example. So we've got EIX in Mumbai, and we've got DKIX in Mumbai. So you can see the number of sites they have, whether they're manners compliant. The IXP can put in here as much information or as little information as they want, but the idea is that the networks or people looking for this information can get a quick snapshot of what is going on. IXPs can also enter their pricing. What they enter in here is completely up to them. But the key thing, I think, we also show is we can see which networks are common. So, for example, for a network who is looking to peer at either of these exchanges can see, okay, well, okay, all of these networks we can get in one place here. And then you can also see which ones are unique. So I've talked about the unique ASs before, and you can see here that these ASs in DKIX has 206 ASs which are unique, and EIX in Mumbai has 82. So people wanting to access these networks would have to peer at EIX, and those wanting to access the networks over at DKIX would have to peer there. So there's a little crossover. What do we have? 91 same networks at both of the exchanges. Then you can actually drill down into the IXP for more further information. I'm not going to go through all the tabs, but you can look at, there's an IXP tab, there's a network tab, there's a points presence, and I've just selected the ASN here. And what the ASN tab shows you, it shows you the networks that are connected to that IXP. It tells you the network name, the type of network, and we collect this from, we get this information from PeeringDB because the networks define themselves in PeeringDB. So for example, for a network that's looking to peer with mostly educational networks, you can actually just sort by education, by the type, and you can see the number of education networks or nonprofits or national service providers, or look at what type of network are you looking to peer with. In most cases, we also have the IP address and MAC address. Again, we can see whether the network is manners compliant, and we get that information automatically through the manners API. So each time a network or an IXP has been approved for manners, that will automatically feed through to us, so we can show that. Something else we do is we show entries that are in PeeringDB. So for example, you know, what we see is, and you know, this is one of the reasons that the IXPs wanted to build this tool, is because not all networks are in PeeringDB. So by using the IXP database, especially when the IXP is publishing its own data, you can very easily see by looking here which networks are in PeeringDB and which are not, which gives the IXP and other networks, it makes it easy for them to chase other networks to try and get their entries updated. We also have an ASN directory, so you can search for ASNs. You can see all of these are sortable. So again, you can sort by type, IP addresses, whether they're manners compliant, and also the number of IXP connections that they have. These are the ones that are reported in the database. You can also compare ASNs if you want to see where are these ASNs present. And I've picked two large ASNs, Akamai and Cloudflare, which I'm sure everyone is aware of. And you can see here, you also, the same thing, you get a snapshot of the ASN, and then you can see how many ASNs, which IXPs they peer at together, which are common. And then you see which IXPs are unique to where they peer. So you would only, so Cloudflare, for example, peers at BoltIX, but not in the Bangkok Internet Exchange. And that's just an example. So you can actually very easily see where is this network peering and where is, where is it not. So where are we? We have last year updated, released a new version of the JSON schema, so it's now on version 1. And now this also includes root server and switch, further details on the switch models and versions, software versions, and also root server software versions and operating system as well. So whether it's Bird, OpenBGPD, or depend on, or whatever root server is being used. We have now API documentation. So if you're interested to hear or see what else what else is available through the API, you can have a look at the documents there. What's new is the traffic. So now, like I showed you, you can just search by traffic. What we're doing is we're encouraging IXPs to adapt the schema, because then, if your data is in there, it can be used for the analysis. I can also tell you that telegeography and CAIDA and other large research organizations are using this data. So if you are appearing at an IX, please speak to your IXP and ask them to export the schema to the database. IXP Manager users already have an export built in. So if you do use IXP Manager, you just need to publish the API. We are in the process of building more tools and visualizations. We want to do things like mapping, so we can see different maps and where ASNs are present and IXPs. And that's hopefully coming soon. So a very quick snapshot of the number of APIs we have in the database. You can see, in Asia, we count 140 IXs in Asia, and out of that, 57 are exporting API to us. Obviously the goal of our project at the moment as well is to increase these numbers. So actually that's it about the IXP database. But I wanted to quickly slip in here. For those of you that don't know, EURIX created a video about 15 years ago. It's a 5-minute video about, and it very clearly explains the roles of IXPs. We have had it translated into multiple different languages, and you can see that on YouTube, on the YouTube channel. However, we're missing a number of South Asian languages. So if anyone is interested in translating the video, it's very easy because we have a timesheet, and it maps very easily to the video in terms of the translation. But if anyone is interested, please contact me. I'd love to try and get it into more languages. And that's it for me. Thank you all very much for listening and your time. Are there any questions?
Yeah, that was. Are there any questions for Bisha? If you can pop them in the Q&A, please. But nobody seems to have anything to ask so far.
Okay. Oh, there's a.
Ah, we have one. What was the video link for IXP?
For the IXP video? You know what? I'll put it into the chat. That might be easier.
Yeah. All right. Anybody else?
The document is already updated.
Okay. Thank you, Kabir.
So the document is already on the site. Anybody can get the URL from the site.
Oh, okay. Sorry. Yes.
Okay. If there are no others, thank you very much, Bisha. Wonderful presentation. Great to hear the update from the IXPDB.
Thank you very much. Bye.
All right. Next up, we have Sharafsal, who will be telling us all about the exchange point in Kabul.
Thank you very much, Philip. It's been an honor to be again with you. I think first time I'm listening from Bijal, and I think I have met Marco in SANOG 35. And I hope that next we can meet from near and another SANOG 37. So I will share my screen for the presentation. Can you see that?
Yes, all good here. Yep. Perfect.
Okay. So as we all know about the IXP, I will come directly to the current status of Nexa. Currently, we are exchanging in Nexa 6 Gbps traffic, which is of 23 per members of local ISPs. But on the pandemic of COVID-19, we connect all the major MNOs, which is AWCC, Afghan Wireless Communication Company, with Etisalat Afghanistan, Roshan Company, which is the local mobile operator here, and MTN, including Aftel, Afghan Telecom. By connecting these, we had a huge traffic and IXP because at the beginning we was exchanging 1 GB or 1.5, but by connecting these bigger companies, we jumped to 6 Gbps traffic right now. With these, as we all know that most of the services, which is local of Afghanistan, that is hosted outside the country, like in Amazon or in Google, but we are trying to bring all the services locally to the Afghanistan, to the National Data Center of Afghanistan, which is in Kabul. When we analyze that the most of the traffic which is in Afghanistan is for the Facebook and Google server, which is Gmail and YouTube and this Google search engine, we thought that we will bring these caches to Nexa. Then at 2018, we brought the FNA, Facebook Network Appliance, this Facebook cache. And on the last year, on the December, we talked with Google company, and fortunately we brought the Google cache also. And right now that is also operational. And the later slides I will also show about the traffic exchange of Google, which is currently for these 23 ISPs we have. At this Nexa infrastructure that is located in the Afghanistan National Data Center, and at here we also host the major services like the online passport. Before we had these issues that this passport and Taskira, we call it a national ID. These was on paper base, but we work and make that one electrical by making these services. We also host that one in the National Data Center, and we also pair these services locally with Nexa. So it means that all the services which are under coverage of Afghanistan, we host them in the local data center, and we directly connect with those services with Nexa. The benefit of that is that we can easily access it without Afghanistan. So that is the major benefit for us currently, that we are utilizing these resources of Nexa and the National Data Center. And during COVID-19 pandemic, that is one example that all the universities and school was off, and some of the people was trying to do to research and to study. We did we connect all the IXPs, all the MNOs to the IXP, and we made a platform for the students of university and schools, that they can easily access the materials of university free of charges. The infrastructure of Nexa was used on that time. We made an agreement with the MNOs, mobile operators, that this we will connect you with Nexa free of charge, but you do what, you just make a package for the university students that they can use your services to access their resources from university and schools. That was a great achievement for the Nexa team on that time. And the second way, we also trying to make other universities or other companies to make the e-learning system that we can host them in data center, and then we connect that to an IXP, our IXP, so that the students and other services will be available free of charge. that was a great achievement on that time for Nexa. Um, as I said, that currently Nexa have this Facebook cache, and that is exchanging huge traffic for these 23 ISPs. They have paired with us, and they're using the Facebook cache locally. I mean, the Facebook contents are locally being given to these ISPs customers. We had a consultancy with a company. All of us know that PCH by name of PCH Packet Clearing House. They have helped us to provide us the root DNS for our IXP. That is also under configuration. We received that on December 2020, and now our colleagues are working to make this root DNS up and operational. That will also help with the ecosystem of internet within Afghanistan. For these, for these cache, we also need a transit link that has been helped with us by the World Bank. They have provided us, that link cost is being covered by the World Bank help. By this project where I'm working, Digital Casa. So we have provided them 1 Gbps internet, and the cache of Google, as I said, this cache is now currently operational. In the next slide, I will show that one also. The currently, I think that's been 2 days that which is operational. Currently, we have just advertised some of the ISP's prefixes to the cache for the checking that how it will operate and how this will work. Later on, we will advertise all the prefixes which we are receiving from our local pairing ISPs. This is the current graph from the Ministry of from the Google cache. Around about 300 Mbps traffic is exchanged. But later on, as this go smoothly, then we will advertise all the prefixes of other ISPs. This is the scenario how our infrastructure of this IXP is built. We have a redundant system. Like suppose we have a Nexus switches here where ISPs are connecting, and ASR routers where we have the BGP pairing with the other all these ISPs. We have root DNS, Google cache, and Facebook cache. We have SANOG for monitoring all the system and service. We are providing services to the ISPs while they have an issue with the their pairing, or they want to block something from an IXP side. We have 24/7 services on our SANOG that they are providing help. Currently on the our IXP, we are providing 1 gig, 10 gig, and even 100 gig connection to all the pairing which we have. And I think right now we have 1 gig and 10 gig pairing, but we also have the option to provide 100 gig port to any company if they want. All the connections from the ISPs to our IXP, that is free of charge. We don't have any cost right now. They're connecting free of charge with us. We have, as I said, 24/7 technical support to all the ISPs. That's like 3 shifts from morning to afternoon, and then afternoon to evening, and then at night. Our future vision for this platform, that we want to have all these ISPs connected with Nexa, with our internet exchange point, and by this we can control all the local data which is currently going outside of the country. our next vision and future plan is that we will connect this cache. We also have we are in debate with Netflix and Akamai that we will have these caches also, but there are some challenges. After that, we will have these two caches also. This is just for the benefit of the local ISPs, which are not that much big, that we will provide these services and this can help them in their business also. This is the vision. In the coming years, we also have to have the regional IXPs. This one is located in Kabul, and that will be on the other sides of the country, like the region which we have Herat, Mazar Sharif, and Kandahar. So this will be 3 other ISPs, major MNOs and other IXPs which are located there. We will connect them on that side also. We also have communication with Asemto IXP. They want to have their appearance in the Nexa in Afghanistan. We are in debate, and for that we will have to make a new policy. Currently, the policy which we have is for the local ISPs, but when we are going for outside the country, that needs a policy which is under the planning team of the Ministry of Communication. They are working to make that policy for the other international connection that they will join, and in the next year maybe that will be also final. We on the local infrastructure, we have the Looking Glass. I have put the URL for that one. We have our website nexa.if, and also we have pairing with the pairing DB. I have also updated that URL also. If anyone wants to check that one, they can check it from this URL. That's it from my side. Thank you for listening, and inshallah we will meet at the next session physically with you guys.
Thank you very much, Sheriff Sal. Yeah, I definitely hope we can meet. I mean, what a change in the status of the exchange point since you presented this time last year in Karachi. I mean, it really has been quite something. Are there any questions at all from anybody?
Yeah, if anyone have.
I mean, so I've one while people are thinking of questions to ask. I mean, what kind of challenges do you have getting the content providers, the likes of Google and Facebook and so forth, to actually locate caches at the exchange point? Because usually there's always a minimum traffic requirement and how to provide transit for the cache full and so forth. I mean, how did you deal with those challenges? Or where did you find that they just said, no, we want our cache there with you in Kabul?
Indeed, the most important thing is that all the local ISPs which are located here, we want to help them on growing their business. The second thing was that we have also a World Bank project in Afghanistan that is working on the government network. They want to build a government network. Currently, we don't have government network. We call it GovNet. So they're also helping us to provide this transit link to these caches. And the second one was that we thought that it will be a big help for the local ISPs to grow their business. So these Facebook, Google, Akamai, or Netflix, appearance of these caches and our IXP, that will help them to grow up their business, because ISPs, local ISPs, they are not in that much shape to provide free of cost contents to the customers. So if Nexa is a centralized location for all the ISPs, they can come, join, and get use of this free service. So on this way, they can grow up. So our aim and vision is that we will help them and grow in their business.
Yeah, no, that's great. I mean, because your model is exactly what so many of the smaller economies, smaller region IXPs will actually do. nobody, not one provider can justify a Google Cache or a Facebook Network Appliance or Akamai. And so what they tend to do is they get together, the exchange point then becomes the natural location for hosting them. So no, I think it's incredible what you've done. And the program committee was very happy to see you propose the presentation again. So, it's, keep up the good work. It's such a good thing to see.
Yeah, of course, maybe on next year when we have SANOG 37, we will have much better improvement because this year we didn't have any activity because all of us know due to pandemic. So next year maybe we will have good improvement by connecting all the ISPs and the traffic will boost up.
All right, that's great. Thank you very much.
Thank you.
All right, so next up we have Marco, who's going to present to us next. Sorry, I was going to say what the presentation was, Marco, but you can do that for me probably way better than I can. Sorry about that. Thanks.
Yeah. Hi, and thank you for giving me the opportunity to talk today. I'm really happy that you put together this program together. I stood up at 4:30 my time, and I'm really happy I did because it was very interesting the whole day. So thank you for all of that and for giving me now the opportunity to talk. As much as I would wish it's not virtual but physical, but inshallah it will happen in one of the next meetings. So my topic today it's the Corona topic. So it is internet in times of Corona and what have we seen on the internet exchange in that perspective. So my name is Marco. For those who don't know me, I'm regional director at DKIX for Middle East and South Asia. And DKIX basically is providing a few exchanges all over the world. So before I start, I want to say thank you to a lot of people who have put together the data where I took some slides out of it. But basically they put together quite a report about how the traffic developed, and you can download it from the DKIX website. There's a white paper about it. So DKIX, very short, we are an internet exchange and our mission is to make easy interconnection anywhere. Having said that, nowadays we have 25 internet exchanges all over the world, almost 2,200 or more than 2,200 ASNs connected meanwhile, and reachable on 500 access points all over the place, and so on and so forth. But important topic, well, how did internet develop or changed due to Corona? As we know, it was a very special moment. I remember I traveled to Capacity Dubai last year, beginning of March, and basically a couple of days before the event was cancelled. So an event of 2,000 people attending, they cancelled from one day to the next because of that virus. And when I came home, 2 days later, the lockdown in Austria started. And so basically, especially in lockdown 1, our physical life was really like paused. So basically nothing was open, and we're now in lockdown 3 here in Austria. I think it's same over the world, all over the world. But now we get used to it. It's, let's say, it's kind of normal nowadays, but well, let's say, especially in March, this was a very unusual thing when your physical life basically gets stopped. Well, let's say lucky enough, we are working in this industry, which means the effect we saw in this industry was maybe different than in other industries. As much the physical life get paused, the digital life got an uptake in all aspects. Trends which were seen before in the digital life were just like boosted. Traffic was boosted and so on. So just to give you a few ideas, so the typical traffic increase which we see per year at exchanges between 10 and 50%. So 10% on the very well established exchanges and the big exchanges, and 50% on the smaller or new exchanges. In the beginning of the crisis, we saw the same increase in just a couple of days. So basically what we see usually during a whole year where we do the year planning, we saw just in a few days. Usually we see a steady growth in fall and winter. Now we saw this traffic growth directly correlating to lockdowns. Of course, when you see a lot of lockdowns in many countries at the same time, as it was in March, where basically the whole world was going into lockdown, then you see it most dramatically when you have these different timings of the lockdowns, as we saw now in autumn. It's a bit more region-wise, let's say. But basically, there's total correlation of traffic peaks and new traffic peaks to lockdowns. Usually, we saw a stable distribution of traffic between the applications. So basically, same browser for video, CDN, and so on. Of course, some trends, but well, they say less stable, predictable. Now we saw an extreme rise of some applications, like collaboration tools. Obviously, Zoom was growing dramatically, and of some applications. And this is, I would say, something which we believe we will see even in future. I mean, just think about what happened with Signal just last week, when they growth from one week to the other, but for other reasons than Corona in this case. And then we also saw this usual cycle of morning to late evening low and between the peak. Now we see total different peaks. And we see the same outcome all over the world in the different time zones on the different exchanges. Which brings me to the first statistic. So this is from this report of the researchers, which I referred before. So they looked at several internet exchanges, ISPs in Europe and mobile operator, and they saw the same thing. When the lockdown started, the internet exchange traffic, no matter if it is Central Europe, Southeastern Europe, US, East Coast, everywhere the traffic increased dramatically, while the mobile operator basically dropped. Obviously, people stayed at home, people used a fixed line internet where possible, which means, but the traffic itself definitely increased in this time. Later on, of course, mobile traffic did increase again, like before, but the internet exchange traffic on most locations stayed dramatically high. The only drop which you see here is the drop of the ISP itself, where you see, okay, the increase of fixed line and then drop again in favor of mobile internet. So the typical workday traffic, which you see, and this is from the point of view of an ISP in this case, is that you see this absolute low traffic during the nighttime, and then it grows steady until evening and then drops again. During the weekend, the traffic pattern looks a bit different, where you have already higher traffic during the day. Of course, maybe also depending on weather, but that's the usual thing which we see on weekends. Also on the exchange, you can see that, because exchange obviously is the aggregation point for a lot of operators, so we see the same picture. And this was the effect of COVID. So basically here you see that basically every workday all of a sudden have the same pattern as a weekend. And interesting enough, this is something which hasn't changed so much also during non-lockdown times, because more and more people stay at home, stay in home office. Home office became very common these days, obviously, even without Corona. So Good example of the traffic is Frankfurt itself. In Frankfurt, we saw from one day to the other more or less a traffic peak of 10%, or traffic increase of 10%. 10% doesn't sound much, but if you're coming from 8 terabit plus, 10% is quite something. So basically, we increased the traffic by almost 1 terabit. And we started with 8 terabit in 2020 and ended with more than 10 terabit end of 2020, which means the traffic did increase dramatically during the lockdown, during the first lockdown in March. But basically, and this is a very interesting message, it stayed. It didn't go away, basically. But of course, we're still in some kind of lockdown situation, but our expectation is it will stay for many reasons. More interesting is the traffic increase of collaborative tools. If you see isolated the increase of Skype, WebEx, Zoom, Teams, and so on, you see a traffic increase of 100% in Frankfurt, which is, if you think that some of these networks are coming from a couple of 100 gigs already, this is quite something. And same is true for gaming. I mean, gaming already had a quite much traffic increase, mainly because of gaming downloads getting bigger and bigger. And we also see this trend to streamed games. So gaming is not only about signaling anymore, it's really about streaming gaming games. Becomes more and more this trend of cloud gaming and so on. So here we will see a lot of more traffic in future, and gaming providers are not, let's say, traffic optimized. They're more looking at good graphics, which means a lot of traffic, obviously. Some other example is DKX Madrid. DKX Madrid, Western Europe. DKX Madrid is the biggest internet exchange in the Hispanic region. Here we saw a total traffic increase of 20%. So also DKX Madrid already had 300 gigabit, if I'm not wrong at this time, of 250 something. So basically this is also something. But even more the collaborative tools. If you think about the traffic increase of 5 times for collaborative tools, this is really something. And as I told you in the beginning, I'm responsible for Middle East and South Asia, which includes the UA exchange in Dubai and our 4 exchanges in India. Especially when I think about collaborative tools, we saw a huge increase there. I give you one example. As it's on PeeringDB, it's not a secret. Microsoft had 40 gig of connectivity with UA Exchange before the crisis. And in the beginning of the crisis, they upgraded to 200 gig. Why? Teams is the main tool there for online schooling. So basically from one day to the other, or let's say from one week to the other week, or this, in our case, to a weekend, because as you know, the Middle East starts on Sunday with their working week. For us, which is basically on a weekend, they needed to upgrade to 200 gig capacity just to be ready for the online schooling in the UAE and in some other GCC countries, which is proving this 5 times increase, which we saw in Madrid as well. Same, of course, true for video on demand. Users stay at home, kids stay at home. I mean, personally, I have 3 kids. I know how it is. If weather is not fine, if you have not the chance to go outside, well, basically what happens, it's a lot of, beside the online schooling, of course, online gaming and sometimes also video on demand. It's something which you almost can't avoid, even if you want, as parent, let's say. What does it mean? What are the possible impacts on the internet infrastructure for us? So basically, in a short term, it means, especially as an internet exchange, we could prove and we could show that internet backbones, internet exchanges could absorb the fast-growing demand. In some cases, it was really hard at the doable, let's say. We know that not only from the IXP, but also from the backhaul perspective, because we're in contact, of course, with a lot of operators worldwide. But basically, it was possible to do this. So this is the basically good news. On the long run, on the mid and the long run, we see that as this capacity obviously stays, so this capacity which was deployed in a couple of weeks, basically nobody canceled it. So Microsoft still has the 200 gig in UAE. Still the big operators, who some of them doubled their capacity on the internet exchange, kept the capacity. So basically this capacity is here to stay, and we see even more capacity which is initiated now to be built, also on the backhaul. And what we also see is these dramatic peaks of specific traffic, so that we have to be able to handle that. I mean, just this outage of signal last week shows how important it is, because traffic shift can happen dramatically fast. Let it be because of such a crisis like COVID and lockdowns, which is very extreme to our daily life, but obviously also other aspects can make these traffic patterns shift dramatically fast, and we have to be ready for this, because extreme situations might occur also in future, and we see how important the internet is to support the daily life then, and we have to be ready and have to provide it. Also, what we see is that the differentiation between business and residential usage is not there anymore, because if more and more people stay in home office, and I know it from Europe that many companies now changing their working contract with the people, where home office will be even demanded, because they saw how much they can save on office space, and we all work in home office, and we know how home office work is. Basically, we basically work more in home office than we would work maybe in an office, because a lot of the interconnection, or let's say the communication which we usually do during coffee break, we don't have it. Whom you want to talk to at home? If your kids are also in homeschooling and everybody is basically occupied by a screen, we do more work. Let it be good or bad, it is as it is. So basically, this is something which will stay. And therefore, and this is what we see on the mid and the long run, at least in our industry, it's our aim to guarantee that the infrastructure and the quality is there, and we will see a lot of more multi-services. I think there was another talk today about traffic slicing, which goes in this direction. We will see multi-service ports, we will see multi-service approaches also on the internet exchange. So historically, so what we saw the enterprise connected to the ISP, and the ISP over the internet was connected to the cloud. No traffic guarantee, no quality guarantee, but same time, most of the servers, most of the infrastructure is on-premise for the enterprise. So cloud is there, but not the most relevant part, let's say. So the shift to cloud was ongoing, but not super fast. As nowadays, more people working from home, working from mobile, it is getting implemented in the culture of a lot of industries who are far away from our internet industry. I mean, we are used to it. We are living this, basically working from everywhere. We're in a conference, but working. We are being home, we're doing conferencing, and we are used to it. So we are used to it in a way that we already see again how important it is to see people physically, I guess. But in a lot of industries where it was unthinkable for people to stay home and work from home, it becomes very common. And as I see a lot of discussions these days where people say, well, when the crisis is over, we want to keep it. We want to stay at home because some say work-life balance is easier to handle. Well, also different discussion. You could do a whole day discussion about this, but basically people want to have it. But also enterprises see the benefits of it. As I said, some people are more productive working from home, and also it's a lot of saving in cost on office space. So basically, we get to prepare for this multi-point or multi-services on the internet exchange. So an internet exchange will be in future not be only the place for interconnecting PGP, it will be the place for interconnecting layer 2 connections to Microsoft Azure Express Route, AWS, Direct Cloud, and so on, and even interconnecting clouds for enterprises. So for getting prepared after the crisis, and I think I need to hurry up, I'm already 20 minutes.
Couple of minutes, please, Marco.
Yeah. So basically, first learning is have some free spare on your internet exchange. In some cases, and I will not tell you now the examples, but in some exchanges it was very close that we were not ready with the usual upgrades before being ready with when the crisis came. So basically, you need to have spare in your capacity, but at the same time means an internet exchange can be ultimately not getting cheaper and cheaper, because having spare is also cost, and we have to price that in on the long run. And this is something which we have to do, and it's our responsibility with the internet exchange. We are cheap, but we can't get endless cheap because of this, let's say, responsibility. Then you need to be constantly in contact with your partners. Let it be the DC partner that you can get into the DC in such a crisis. Carrier partners to ensure the connectivity is there. Hardware vendors that they can deliver you and handle also certain restrictions on customs, for instance, to get hardware into a country, even during a lockdown. Delivery is a very important point, so you need to be really close with them, or have hardware on stock for that aspect. And we all need to work hard that everywhere in the world IXPs are treated as critical infrastructure. So in different, as we work worldwide, we see this in different markets, it was treated very different, and it took, in some markets in particular, it took quite some time to be empowered by the local authorities that our employees could go to the data centers and do some needed maintenance work and so on, which is really critical, because without that, the internet would not work. So this is a very important thing for all of us. So in future, we will need even more to build the awareness and the acceptance. So digital is on top of physical, not instead of it. This is also clear, but it's a very important part, and it goes across the entire society. So basically, the responsibility has become bigger for us even, and we need to work on all aspects to make this also clear. Connection will be everywhere, with everybody and everything, and basically we are globally interconnected. I gave you this example of Teams before in the UAE, and in order to serve that, not only they needed to upgrade capacity in the UAE, they also needed to upgrade backhaul capacity. And I know that in the end of the day, the whole team setup for the UAE was hanging because it was close to impossible to get some cross connects in Frankfurt on time for them. So it shows how interconnected we are, but which brings me to the next topic, closer to the edge. OTTs know it, they're working on it, but we see how important it is to go even closer to the edge. So that's why I'm very happy to hear that there is an internet exchange in Afghanistan, and I hope that the OTTs will, on the long run, and we also heard it today earlier in the session in Nepal, I hope that the OTTs will not only serve caches there, but really build POPs, because if you think Nepal, a market with 30 million people, there should be an edge node of some of the big OTTs if you think of the traffic. And I think for the richest companies on the planet, it should be also part of their responsibility to invest a little bit in those markets where it's not so easy. So we will see more cloud and content applications for sure. And we also will see more interconnection, not only on the internet exchange, not only on the PGP side, not only this public interconnection, but also closed interconnection between different groups. We call it closed user groups on the internet exchange, where enterprises are connecting each other to be more stable. And this will come together with more automation. We need to be ready for more platforms, APIs, self-service platforms, and so on and so on. And this has to go across multiple providers, channels, and so on. And we need to share this knowledge. This is something which is really important, as everything is working together globally these days, and the COVID crisis showed it. Well, it's more or less a wrap up what I have said before. The internet interconnection has to be everywhere. It has to be self-serviced, automated, and we have to be aware of all this, of its importance. So basically, the closing word is let's build it together, and let's go more to the edge, and let's hope we can talk this next time physical. Thank you and stay healthy. So are there questions for this part, or shall I go over to the RxP update directly?
You've got one question. I don't know if you want to answer that first, or...
How can you establish resilience in your view of a shifting market? Well, the resilience part obviously can only well, as I said before, we had good luck that we always planned with some percentage of unused capacity. Obviously, this comes with cost, and we got a lot of criticism for definitely not being known as the cheapest internet exchange on the market, and commercial exchange and so on. But the point is, and this is something which also turned out, is if you're not ready for a growth, if you don't have the potential to grow, and you don't have that, you can't deliver. So basically, my take of it is that as internet exchanges, we should maybe more work together and less compete in some aspects, and say, how can we make the internet stronger, and also maybe help out each other in such a crisis with hardware or whatever. Because if you don't have that on the possibility to handle a certain growth of 30%, it's undoable. But you know, it comes with cost in normal times, and you need to be able to do that. So this is, I would say, it's a tricky answer, especially for small exchanges, which I know because I'm responsible for small exchanges, where budget is always a huge limitation, of course. But you have to be ready to. You have to be ready to do this. Okay, homeschooling. You have heard just in the background. So, okay. I hope that answered the question. Shall I go to the RxP?
Yes, please,
short?
if you do that. Yeah.
Okay. The screen is open again. So, just very short. DKIX India. I'm responsible for it. We operate in 4 cities right now. In Mumbai, Delhi, Chennai, Kolkata. In multiple locations everywhere. Currently, we're number 2 largest exchange in the APEC region with Mumbai. And we launched our direct cloud service as well in India now. So basically cloud is available on the exchanges there, and we will come up with more services this year. So if you have any questions, just send me. And DKIX worldwide, well, basically I will not go through the list. It's 25 cities worldwide, markets. We have more than 500 POPs where we are available worldwide now, more than 2,200 AS numbers, 68 terabit of combined traffic peak, route server available, RPKI available, and so we are strongly advocate for it. If you were we are not available with that in India, but this is the big plan, or was the big plan for 2020, but now in 2021 we will finally do it, because we see the importance and definitely are advocates for this. Recent updates, we implemented the Maps Microsoft Azure peering service in 2020, which is basically exactly the answer from Microsoft to make Office 365 better available for enterprises and home working. And we opened new exchanges, not only in Chicago, Richmond, but these are the newest ones. Thank you. That's it from my side.
That's great. Thank you very much for that, Marco. And for everybody else who's watching, we only got one peering personal, IXP personal. So hopefully next SANOG around, we will get a lot more than this. But if any of you didn't know what an exchange point personal was or a peering personal was, exactly what Marco did. It's an opportunity for a network or an internet exchange point to basically say who they are, where they are, what they are, size, expectations, and so forth. So we only had one this time around. I guess most people expect at an in-person event, you can just turn up at the last minute, but obviously with a virtual event like this, we can't just turn up at the last minute. So we need to gather all these peering personals and exchange point personals in advance. So other entities will be like this, and not to advertise Apricot or anything, but we'll be doing exactly the same thing, Apricot 2021, all the peering personals and exchange point personals we have to collect beforehand, and exactly in the format that Marco did it. So hopefully for those who are listening and watching, you can get your thinking caps on and start thinking out what your peering personals and exchange point personals are. We now have another question for you, Marco, from Manoj. I don't know if you can see it. Or if you want to answer it now or take it offline or whatever, because we are out of time. So
yeah, I can answer it. You can drop me an email and we can discuss it, or I'll forward it to the people who did this certification. We don't have that all over the world. We definitely have that in Germany, and it was a precondition for some big enterprises to connect, because Mercedes and Porsche and companies like that are going to internet exchanges these days because of 5G and IoT. And this was a precondition. This is how much I can tell you, how it really improves. Well, it maybe makes you, okay, I answered already, so we don't need the email. I think that the real improvement is that it makes you aware of certain topics that you also know to handle it. And well, let's say, and then take it for the other exchanges where you really see a use in it. Okay. I hope this answers it. But basically it was a precondition for big companies to connect in Germany. That's why we did it. And if you want to have more information, drop me a note. My email was there on the slides, and I can forward it to the people who can give you an in-depth explanation where they see the benefits for different sites.
All right. Thank you, Marco. So that brings us to the end of the session. I'd like to thank Bichao and Sherofsal and Marco for excellent presentations, really interesting stuff. Thank you for spending the time putting these together, for us and presenting them, well, this evening here in Brisbane, this afternoon in Kathmandu, and early morning for you and Bijal, Marco. So we resume with SANOG 36 tomorrow morning, 10 a.m. Nepal time. Just to give you an advert for that. Please join in good time. We want to start at 10 a.m. Dave Phelan will be your chair, and we're looking at Network Management and Monitoring 2.0 from Hervey Allen of NSRC, route views from David Teach, and some chap called Philip Smith will be talking about internet routing table updates. Otherwise, that brings us to the end of the session. Rupesh, I don't know if you want to add anything. Otherwise, we can resume tomorrow morning. Enjoy your evenings, the rest of your days. See you then.
Thank you, Dr. Philip. Thank you, Marco, Sirajal, and Bijal for the excellent presentations. I think we had some issues today morning, so really apologize for that. So I hope all the participants who are there today would participate tomorrow morning as well. And I think there are a lot of other presentations as well as tutorials tomorrow. So hope to see you all tomorrow. And thank you very much for participating today. Thank you.